Hello everybody, my name is Hezekiah. So in this video I am going to be deriving a closed form solution of Fibonacci sequence recurrence relation and then simulate that sequence in a MATLAB programming language. Okay, so I'm talking about deriving closed form solution for Fibonacci sequence. Okay, now Fibonacci sequence is a popular sequence in discrete mathematics, in engineering, in science. It's very popular, and it's the name of a scientist, I believe. It's the name of a scientist, Fibonacci, and it has got something to do with rabbit reproduction and population. It has got something to do with what? Rabbit reproduction and population. Okay, so if you want to know more about Fibonacci sequence, all you have to do is just to Google search information about Fibonacci. But I can start with the numbers. Actually, according to history and according to the nature of the sequence, if you start with zeros and one, you want to generate sequence of numbers. The next one is going to be the sum of the two previous ones. So if you had 0 and 1 together, you get 2. You get 1. So now, this is the current. Now, between 1 and 1, 1 and 1, if you had 1 plus 1, you're going to get 2. Okay, if you had 1 plus 2, you're going to get 3. If you had 2 plus 3, you're going to get 5. 3 plus 5, you're going to get 8, and so on and so forth. So the sequence is defined as what? Next equals what? Sum of two previous terms. Okay? In other words, if you have a sequence of number, let's call it Fn. Before your Fn, now I'm using F because most textbooks use F to give honor to the man that discovered the sequence, Fibonacci F. I could have used T for times. So before Fn, I will have Fn minus 1. And before Fn minus 1, I should have Fn minus 2. And if I move to the right side of Fn, I'm going to have Fn plus 1, Fn plus 2. Now, those n's here, they are just index. Positional index of position. Okay? Right? And we don't want to have negative index. You could have negative index to the left side. But, so, by this formula right here, you can say that your Fn is going to be the sum of the two previous ones. Fn minus 1 plus Fn minus 2. And your n must be greater than or equals to 2. Okay. Because your f must be what? Greater than or equals to 2. So you have to start minimum of n to be what? 2 here. We don't want to see negative for a reason. Okay? And that is the sequence. And the first number here was, this is called initial one, T0, and this is called T1. Now, it is not called T0 because it is 0 here. It means at the beginning of time. Initially, the time was 0, so T0 is 0. Because you could start from, if you start from 1 and 1, so your T1 is 1. So, okay, so you have this sequence, right? With these two initial conditions, T0 to be 0 and the value of T1 is 1. Now, again, it is not 0 here because this is 0. No, that is just the value of the first two times. So your T1, according to this definition, is going to be, in fact, I should use F. Okay, sorry about that. Your F0 is 0 and F1 equals 1. So if I want to get my F2, F2 is going to be what? F0 plus F1, which is 0 plus 1, right? So you need to specify the restriction on n and the two initial conditions, F0 equals 0, F1 equals 1. So that is the complete definition of Fibonacci sequence. Okay, now how do we derive the closed form solution for this? So step number one, okay, make sure you know what you are working on. So you can write out the original equation, write out the original sequence. Okay, now remember you have to keep this at the back of your mind, the two initial conditions. Now you move, this is equation 1. Now rewrite this equation and move the right side to the left side. So you are going to have Fn minus Fn minus 1 minus Fn minus 2 equals to 0. That becomes your equation 2. Now again, all these Fn, n minus 2, they are just subscript, like first person, second person, third person. I can have P1, P2, P3. So person 1, person, just like that. Okay? So now you move that to the left side, and step number 3, write the associated characteristic equation for equation 2 here. Now, when we talk about characteristic equation, it is just a quadratic, it's a polynomial of degree 2, quadratic function corresponding to the f's here. And then you know in a quadratic function, the dominant guy, if you are using x variable, is the x squared. Now, if you look at this expression, Fn is the leading guy. So that will correspond to what? If I write it out here, so that means I would generate a quadratic function in variable x squared, minus, the power will be reducing now, minus x1, because the coefficient here is -1, right? Then minus x0 equals to 0. Now look at how the power was reducing. That's how to form it. And you can rewrite this actually as x squared minus x minus 1 equals to 0. Okay, now you have to solve. You have to solve this simultaneous equation. That will be your, quadratic function. That will be your step number 4. Solve the quadratic equation, right? And if you solve this, you cannot readily factorize this, so you have to compare this equation here with the general one, ax squared plus bx plus c equals to 0. Your a here is 1, b is -1, c is -1. You are going to make use of the formula x equals minus b plus or minus b squared minus 4ac all over 2a. Now, you are going to, when you solve that, of course, you are going to have two solutions. So x is going to be minus 1 plus or minus -1 squared minus 4 times A. Our A was 1, C was negative 1, and all over 2 times 1. And if you do this properly, you're going to have x equals 1 plus minus 1 plus 4 all over 2, which is 1 plus or minus square root of 5 over 2. So the two solutions here are what? X1 equals 1 plus root 5 over 2, and x2 equals 1 minus root 5 over 2. You see that? Now, when you have two different roots, we are looking for an expression, the closed form solution of this, for this sequence, so that we can use that expression to forecast or predict any terms in that sequence. Okay, that is our objective, and I'm going to solve it. After that, use MATLAB to plot the graph. Now, when you have, according to the method of characteristic equation, when you have two different roots for your characteristic equation, x1 and x2, you are going to assume this formula, Fn equals a x1 raised to power n plus b x2 raised to power n. Now, x1 and x2 are already given here, and a and b are constant to be determined. Okay, now we've got two initial conditions, f0 equals 0, f1 equals 1. Again, f1 is not 1 because you have 1 here. No, that is the nature. You could, if I like, I can start my f0 to be 4 and f1 to be 5. Okay, but for this, to make it easier, you have to start with f0 equals 0 and f1 is what? You call these two initial conditions. Initial conditions, okay? So case 1, you have f0 equals 0. In this case, your n equals 0, right? So, and that will be a, x1 is 1 plus root 5 over 2 raised to power 0, because your n is 0. See that? Plus b into 1 minus, this is b, root 5 over 2 raised to power 0. So just forget about this side and focus on here. So it's 0. If anything to power 0 is 1. So this is going to be what? A plus b. So this is equation 1 for case 1 using the initial condition 1. Okay, now case number 2. Case number 2, I have to use the second initial condition, which says f1 equals 1. In this case, your n is 1. So that will be a into, again, our x1. Our x is 1 plus root 5 over 2. Now, this time around, it's going to be raised to power 1 plus b into 1 minus root 5 over 2 raised to power 1. That is equation. Let me call this equation star. This is equation star star, because I already have 1 and 2. Now, you have two equations to be solved simultaneously. Let me do this properly. And that will be 1. There is 2 here, right? I can multiply everything by 2, so I'm going to have 2 equals a into 1 plus root 5 plus b into 1 minus root 5, because this is to power 1 already, okay? That's equation star star, right? I'm just trying to rewrite it. Now, if I expand this further, I'm going to have 2 equals a plus a root 5 plus b into 1, b plus b minus b root 5. So essentially, I now have these two equations, a plus b equals 0, writing it out again, that is equation star, and a plus a root 5 plus b minus b root 5 equals to 2. See these two? That is equation star star. Now I'm going to solve these two equations simultaneously to get the values for a and b. Then I can plug the values into this expression to complete my solution. Okay? Remember, why am I using this? This is the formula for when you have two different roots, x1 and x2, not the same. This is the formula to use. Okay? Now from 1, I know that a plus b is 0, right? In 1. So if I look at a plus b here to be 0, I'm going to have a plus b plus a root 5 minus b root 5 equals to 2. I'm still on equation 2. But from equation 1, a plus b is 0. So this is 0 plus a root 5 minus b, this is root 5, b root 5 equals to 2. So if I go on that way, I will have, now, at the same time, from here, you can already say that your a equals to negative b. See that? So I'm going to have, this is 0. See, a plus b is 0. Right? From here. Then, that is gone. Then I'm going to replace a as negative b. So my a is negative b root 5. Then negative b root 5 equals to 2. And then I will have negative 2b root 5 equals to 2. And that gives me b as 2 all over negative 2 root 5. And this cancels this, giving me what? Minus 1 over root 5. That is the value for my a, for my b. Therefore, but a is negative b. So therefore, a is 1 over root 5. So I got values for my a and b. That is very, very cool. And the closed form solution, when you have two different roots, x1, x2 for the characteristic equation, the closed form solution is what? Fn equals a x1n plus b x2n. We know that x1 is 1 plus root 5 over 2, and x2 is 1 minus root 5 over 2. Okay, so just plug them in here. You have your Fn. My a is 1 over root 5, right? So 1 over root 5 into my x1 is this. 1 plus root 5 over 2 raised to power n plus, now, plus my b is negative. My b is negative. See, my b is negative here. So that will be negative 1 minus root 5 over 2. That's my x2. My x2 is this, raised to power n. Now, this is the closed, this is where I'm going, closed form solution for the popular Fibonacci sequence. You see that? That is the closed form solution for that. Now, you can use this formula to generate, to predict, to generate any sequence, any numbers, any Fibonacci numbers. Okay, that is very interesting to me, I think. Okay, so now look at this formula right now. Yeah. In case when you solve your quadratic and you get x1 to be equals to x2, you are going to use separate formula as what? ax1n plus bnx1n. Remember, in this case, your x1 and x2 are equal. That is for perfect square, but that is not the case here. In this case here, we have two different roots. So you are going to make use of this. Okay, so the Fibonacci, this formula for generating Fibonacci numbers is now giving us what? 1 over root 5. 1 over root 5. Let me see what I wrote down. Okay, yeah. 1 over root 5 into 1 plus root 5 over 2 raised to power n minus 1 minus root 5 over 2. See, all of them over 2 raised to power n. So now I can now say, for instance, if I'm looking for the 51st time, we just be what? 1 over root 5 into 1 plus root 5 all over 2 raised to power 51 minus 1 minus root 5 over 2 raised to power 51. So this is a function. So I can get any. So you can use this for what? Forecast. So the essence of function in calculus is what? Prediction. Okay? Now, that is the closed form solution for Fibonacci sequence. Again, look at it. Very nice solution. 1 over root 5 into 1 plus root 5, all of them over 2 raised to power n minus 1 minus root 5 over 2 raised to power n. Right, that is great. Now, let me switch, turn over to what? MATLAB Windows and show you how that was coded in MATLAB. Now, this MATLAB version 2022, see version, right? 2022, look at that. Now, here, I want to determine how many Fibonacci sequence I want to generate. Maybe 10 of them or 25 of them. Okay, that is line number 2. Then line number 3, fib, is like a container that contains those numbers, zeros. Now, this one is to hold. This will hold all the numbers. Okay? Now, let me explain to you the nature of the zeros. Okay? If I say fib equals zeros 1 to 10, see what I have. Initially, it's going to give you 1 by 10 row vector to hold 10 Fibonacci numbers. The first one, second one, third one, fourth one, fifth one, sixth one, 7, 8, 9, 10. But as you begin to generate the formula, whatever you get in this line 5, based on the value of your I, we replace all the zeros. So initially, get a sack, like a bag, a container, to store all the Fibonacci numbers. So you have that. And then you have to use the for loop for I equals 1 to how many? Use this formula. Now, the formula I use here is the formula I got from that recurrence relation. Look at that. Look at it. 1 over square root of 5, blah, 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 is for I. Exactly. That is just this formula right here. Okay? Now, I've got that, and I need to round up because I need to use the floor function here so that my result can be what? Integer numbers. Okay, and that is also what is called a golden ratio. Let me quickly talk about that. So if you have several Fibonacci numbers, F1, F3, F4, blah 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 blah, maybe Fn. Now, golden ratio, which is represented as phi, is given as limit of next, ratio of next over previous as I approaches infinity. As the numbers, as you generate more Fibonacci sequence, like 1,000 of them, 150 of them, this golden ratio will be close to, I think it's 1.61 something, approximately, right? And I'm sure that is exactly the 1 plus root 5 over 2. I think that is the golden ratio, if I'm not mistaken. But don't pick me on this. Okay? Just know that when you take the ratio, the limit of this ratio, next, this is the next one, this is the previous one in the Fibonacci sequence. As your I approaches infinity, I means as you have more terms in the sequence, you have what is called a golden ratio. And if you go back to MATLAB here, see that here I've got fib n. N is the last number in that sack, in that bag, and n minus 1 is the predecessor of n. So it's like 10th items is your n, 9th item is your n minus 1. Okay, that is how to do that. Okay, so for instance, let me give you this number. Let me say fib equals 145,999. Now this is a row vector. See, this is a row vector, right? Now the last number here is 4. If I say fib of end, that's going to give me 4. See that? That is awesome. And if I say fib of n minus 1, that will give me 3. See that? That is exactly what I did here. The ratio of the next over previous. Okay, then I want to plot everything right here. And this is a LaTeX function, LaTeX code to type in the formula and put the formula onto the graph. This is how you do that in your MATLAB. This is a type 2 function. This is a label, X label. This is X label and the Y label. So if I run this code right now, the code is going to request for how many Fibonacci numbers do I want. Say I want 25 of them. I'm going to run it, and then I've got result right here. See what I've got. Oh, look at all the Fibonacci numbers, right? And if I want to say I want to display the numbers out, look at the golden ratio. I told you. Now let me try the golden ratio here. 1 plus square root of 5 all divided by 2. See what I got? Yeah, I was right. So this is a formula for golden ratio. Okay, golden ratio is right here. Where is it? Golden ratio is right here. 1 plus root 5 over 2. Or you just take the limit of next one over previous one as your I approaches infinity. That will give you approximately phi. We have phi is what? 1 plus root 5 all over 2. Wow. So let's see the graph again. Okay, I think I want us to see the numbers. So let me remove and run it here. Okay, let me have 25 of them. Okay, so look at Fibonacci numbers. It's a lot. It's really a lot. Okay, so that is the end of, and I think there is a function. There is a function. I think there is a function. Let me format short. So then I'll call this 25. Okay, so yeah, these are just the numbers. Okay, I think it's formatting it in a funny way. It's still the same numbers, and there is a formula in MATLAB called a standard function that you can use to generate Fibonacci numbers. How? Oh no, that is the 25th one. Let me see. One. I'm not sure that was right. Might be right. Too many. Okay. Let me see. Help. I don't use that number. I just write my own function most times. Fibonacci. Help. Fibonacci. Okay, so I can look for documentation on that. Okay, I see the point now. N equals to 1 to 10, Fibonacci n. Okay, so if I want to call that function, I equals 1 to 25. Okay, Fibonacci I. Okay, now that gives me all the first 25 Fibonacci sequence. In MATLAB, it assumes the first two are 1 and 1, not 0 and 1. You know, some people implement the two initial conditions to be 1 and 1, not 0 and 1. So these are if you add up 1 plus 1, you get 2. If you add up 1 plus 2, you get 3, and so on and so forth. This is a Fibonacci what? Sequence. And if you divide this number here by this one, you will get 1 point something. Let's see that. 75025 divided by 46368. Look at what I got. That is the golden ratio. Remember, this is what? Tn divided by Tn minus 1. Okay? I hope this is very informative. I know this is a long video. I just purposely extended the time to make it self-explanatory. And I hope this is very informative. Please don't forget to subscribe to our channel, like this video, shoot me if you have any suggestions. If you want me to do any special video on this, just let me know. Thank you, and have a wonderful day.